Hello everybody. Today I can determine if an outcome is expected by finding the confidence interval and determining if the given value is inside the confidence interval. Part 3. So these are 4-point questions on the regions. They are very commonly asked 4-point questions on the Algebra 2 regions, and they're really pretty straightforward as long as you learn how to do them. There's a lot of words in the problem which can scare a lot of people, but the math itself is really pretty straightforward. So to make things pretty simple, what you're doing is kind of listed here. You're going to find the confidence interval, and the confidence interval is the mean plus and minus 2 times the standard deviation. And then you're going to determine if the given value is inside or outside of the confidence interval. If inside, it's an expected value. If outside, it's not an expected value. All right, so let's take a look at the first example. A radio station claims that the mean number of minutes commuters listen to the station is 30. The station conducted a survey of 500 of their listeners who commute. The sample statistics are shown below. The simulation was run 1,000 times based upon the survey. The results of the simulation appear below. Based on the simulation results, is the claim that commuters listen to the station on average 30 minutes plausible? Well, we're using this information to find the confidence interval, specifically right here, the mean and the standard deviation. When you're using the confidence interval, you're doing the mean and standard deviation of the sample distribution. So my confidence interval is the mean plus and minus 2 times the standard deviation. It's 29.101 plus 2 times 0.934. And it is 29.101 minus 2.934. So let's pull up my calculator and find out what those are going to be. And we've got 29.101 plus 2 times 0.934, and then we've got the minus of that. So it says that it wants us to round. It says explain your response including an interval of the middle 95%. That's the confidence interval that it's asking for, round to the nearest hundredth. So we're going to round these values to the nearest hundredth. So that's 27.23 to 30.97. And it wants to know if 30 minutes is plausible. Well, is 30 minutes inside the confidence interval? Is it between these two values? Yes. So yes, 30 minutes is plausible because 30 is inside the confidence interval. Avoid saying it. I know I mentioned that in previous videos. Say the value that is inside or outside. Avoid using the word it. And that's it. It's a 4-point question in the Regents. You're gonna find the confidence interval. You are going to take a look at the given value, and you are going to see if it's inside or outside. Now, again, a lot of times there's a lot of words in these questions, so if the words confuse you, find the confidence interval, pick out whatever the given value is, and see if it's inside or outside the confidence interval. Charlie's Automotive dealership is considering implementing a new check-in procedure for customers who are bringing their vehicles for routine maintenance. The dealership will launch the procedure if 50% or more of the customers give the new procedure a favorable rating when compared to the current procedure. The dealer devises a simulation based on the minimal requirement that 50% of the customers prefer the new procedure. Each dot in the graph below represents the proportion of the customers who prefer the new check-in procedure, each of sample size 40, simulated 100 times. Assuming the set of data is approximately normal and the dealer wants to be 95% confident of its results, determine an interval containing the plausible sample values for which the dealership will launch the procedure. It's asking for the confidence interval. Confidence interval is the mean plus and minus 2 times the standard deviation. I want you to pause, calculate the confidence interval, and then unpause. Okay, so I'm using these values right here. The mean plus 2 times 0.078, the mean minus 2 times 0.078. Go to my calculator, 0.506 plus 2 times 0.078. And then I'm going to copy and paste that and put the minus. And does it want me to round to anything? Yes, it says nearest hundredth, so that's 0.35 to 0.66. Make sure you're going smallest to largest. Whenever you're writing an interval, it's always smallest to largest, 0.35 to 0.66. And again, I'm rounding because it says to round to the nearest hundredth. 40 customers are selected randomly to undergo the new check-in procedure, and the proportion of customers who prefer the new procedure is 32.5%. The dealership decides not to implement the new check-in procedure based on the results. Use statistical evidence to explain why. Well, my value is 32.5%. So, of course, it's going to be easiest to make that into a decimal. So 32.5% is 0.325. I want to see if that value is inside the confidence interval. It's not. So it's telling you the answer. It's telling you that they're not doing it. So the reason why is 0.325 is not in the confidence interval. And again, avoid from saying it. Don't say it is not in the confidence interval. Say whatever the value is or is not in the confidence interval. The only little help I want to give you for this one, let's just take a read through it, but I'm going to have you mostly try it on your own, but let's just take a little read through it. Mary bought a pack of candy. Good for Mary. The manufacturer claimed that 30% of the candies manufactured are red. In her pack, 14 out of the 60 candies are red. She ran a simulation of 300 samples. So, the value it's giving you is 14 out of 60. In order to see if that's going to be inside or outside of the confidence interval, you have to make that into a decimal. How do you make that into a decimal? You divide. If it wanted a percent, I would divide and multiply by 100, but since if you're looking at the mean, the standard deviation here, since they're decimals, we want it to be a decimal. So 14 out of 60 is 0.23 repeated. So once you find your confidence interval, that's the value that you're looking at. So if they give you a fraction you need to make it into a decimal. So, outside of that, just like for the other problems, we're going to find the confidence interval. We're going to identify the given value and see if it's inside or outside. So at this point, please pause, try number 3 on your own, and then unpause. Okay, now that you tried number 3 on your own, based on the simulation, determine the middle 95% of plausible values. It's asking for the confidence interval. So the confidence interval is the mean plus and minus 2 times the standard deviation. Those values are right here. 0.301 plus 2 times 0.058, 0.301 minus 2 times 0.058. 0.301 plus 2 times 0.058 minus, it doesn't say to round, so we're not going to round. We have 0.185 to 0.417. And again, always go from smallest to largest whenever you're writing an interval. Based on the simulation, is it unusual that Mary's pack had 14 out of 60? Well, 14 out of 60 is 0.23 repeated. Is that inside the confidence interval? Yes. So is it unusual? No. 0.23 repeated is inside the confidence interval. Again, notice I did not say it. I'm listing the value every time. That's basically it. They can get a little tricky with this, coming up with this value, but outside of that, it's really a very simple, straightforward 4-point Regents question. So let's take a look at like one more together, or not together, but let's take a look at number 7. Again, sometimes there's little twists on coming up with the value. So why don't you try number 7 on your own? So please pause, try number 7 on your own, unpause. Okay, in a random sample of 250 men in the United States, age 21 or older, 139 are married. The graph below simulated samples of 250 men, blah, 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 blah. Based on the information and the simulation, create an interval in which the middle 95% to the nearest integer, it's asking for the confidence interval. So the confidence interval is the mean plus and minus 2 times the standard deviation. It's 138.905 plus 2 times 7.950. And it's 138.905 minus 2 times 7.950. And 138.905 plus 2 times 7.950. And then I put the minus. And it sets the nearest integer, and it's always smallest to largest, so that's 123 to 155. That's 2 Regents points right there. B, a study claims that 50% of men 21 and older in the United States are married. 2, results from Part A contradict this claim. Now, these are not percents. These are not decimals. This is a quantity. This is the number of men out of 250. So if it wants you to look at 50%, you have to find 50% of how many men are in each sample, which is 250. So you have to do 0.5 times 250, which is 125. That's the value that you're looking at. And that was a little twist. Because the confidence interval represents number of men, it's a quantity. If it wants 50%, you have to find 50% of your sample. So, do you agree? Do your results from Part A contradict this claim? It says that 50% of men. Well, 50% of 250 is 125. 125 is inside the confidence interval. So no, it does not contradict it. Because, again, don't say it, but say 125 is in the confidence interval. So, very commonly asked 4-point Regents question, very straightforward, commonly asked 4 points Regents question. When you see these these sample distribution problems, you're going to find the confidence interval using confidence interval equals the mean plus and minus 2 times the standard deviation. You're going to determine if the given value is inside or outside of the confidence interval. It might give it to you directly. Here it says, 30 minutes. Or you might have to do, 14 out of 60 is 0.23. Or you might have to do something here where it said 50%, so you had to find 50% of 250 to get that. So you might have to do something in order to come up with that value, or you might not. Either way, once you have that value, you're going to see if it's inside or outside. If it's inside, it's an expected value. We're going to expect that happens. If it's outside, it's not an expected value. Your classwork/homework is to finish this assignment. Again, a very, very important assignment because it's a very, very commonly asked question on the Algebra 2 Regents. And I hope everyone has a great day.